right. Welcome back from Thanksgiving, and I hope you're ready for a new lesson. And this one is on properties. That's my husband's job's real estate, but I don't think that's really what properties are talking about here. So let's see what they are. The purpose of these two properties, associative and commutative, is so that we can write equivalent expressions. And of course, this chapter is all about expressions. So let's look to see what that means. First of all, associative. Associative means that I can group things in any order that I want. So if I have A grouped with B with a grouping symbol, and then added to C, I could change it so that now it's exactly the same. It's equivalent. Because it's addition, I can move those parentheses and it'll still be equivalent. You'll see that that's useful later on. Obviously, in this situation, it doesn't make a bit of difference, but it'll help you in algebra. Commutative, you're more familiar with. That means I can actually move, not put grouping symbols in, but move things around. So this time, let's say it's multiplication. So it's A times B times C. In commutative, we say that's the same thing as C times B times A, or B times A times C. So these are two first properties that we're going to deal with, and let's see how that looks. All right, here's associative. So we're going to add A, B, and C together, which is obviously mathematically correct, but it doesn't mean anything because we don't know the value of those numbers. But let's say we knew some of the values. So in this case, A is 6 and B is 12. And if I know what they are, I don't want to use order of operations and add 12 to C because I don't know what C is. But I could regroup them, and I could rewrite them as parentheses 6 plus 12 plus C, and then I could partially evaluate. I can't finish it, but it's 18 plus C, or C plus 18. What if I had multiplication? Same thing. If it's A times B times C, it's meaningless because I don't know the values, but once I start discovering what some of the values are, it is much more helpful to have my parentheses around the 6 and the 12 instead of the 12 and the C. So I'm going to move them around so that it's 6, and then because they're numbers, we'll have to put that little dot in to show that we're multiplying, and then that's times C. And 6 times 12, of course, is 72, so this can be rewritten as 72C. So these are ways of simplifying and still having them all be equivalent. All right, next idea. How about if we're doing commutative property? I want to move things around. Length times width times height can be set in any order to find the volume. So if we have 20 times the width times the 5, so we know the length and the height, we can rewrite that. So it's 20 times 5 times W. And then it's pretty easy to see that this can be simplified to 100 times W. If it's addition, and let's say we're trying to find the perimeter of something, so we're adding 2 lengths and 2 widths. They may or may not be the same. It could be, those lengths don't have to be the same. You don't have to have a rectangle to have a perimeter. It could be some kind of a polygon with 4 sides and still have a perimeter. But we'll call the 2 longer sides lengths and the 2 shorter sides widths. And let's say we know one of the lengths, and that's 8. and we know one of the widths, and that's 3. It would be more helpful if we could combine those 8 and 3 together so that maybe I don't have to work quite so hard to find these other two. So length plus width plus 8 plus 3. So notice I've changed the order so that I can rewrite it in a little bit more simple fashion. Right, so we have now simplified by using equivalent expressions. And now we're going to deal with ones and zeros. What effect do those have when we're working on this process? You're going to be solving some problems tomorrow, and sometimes you're going to add a 1 or add a 0, and you'll understand it a little bit more tomorrow. But right now, let's just take some notes so that you know these properties. So there's this property of addition that says if I add 0 to anything, it doesn't change it. So write in doesn't change. So I can add 0 to anything. But if I add 1 to something, it definitely increases. So that's the property of addition. Now, so we actually, let me just say this. We actually don't use that as a property. Adding 1 to anything increases it, so it's not an equivalent expression. But if I add a 0, it is equivalent. Multiplication, notice, does a bit different thing. If I multiply anything by 0, it doesn't exist. It equals 0. It's another way of saying n is not even there. However, if I multiply a number by 1, it's the same as adding a 0. It doesn't change. It stays the same. So there you go. Kind of a look at what 0 and 1 do depending whether you're adding it or multiplying it. So if you're talking about keeping things equivalent, adding 0 keeps it equivalent, and multiplying by 1 keeps it equivalent. Adding 1 or multiplying by 0 does change the situation. All right, be ready for some practice on these tomorrow, and I think we finished this in short enough time that your notes shouldn't be too bad.